Okay, we're in section 31 of the notes, and this is going to be the assignment related to the assignment on slopes. All right, we'll certainly go through this again. The policy is really short lecture, and we'll go through that. All right, so, and we'll certainly start doing examples after we get through the lecture. All right, so let me switch over to the whiteboard. And we'll do it one step at a time. Okay. And this is critical that you know slope is being defined a certain way. And again, when I say it's defined a certain way, you'd have to know how they would define slope for a line. All right, so let's talk about this. We're talking about the slope of a line. All right, so we've graphed a lot of lines already, and we've repeatedly seen patterns and how points have changed. And you may remember this. We talked about how the x's were changing, if they were going up, if they were going down, and how the y's were changing, if they're going up or down. This is really, really important, how those points change on a line, all right? We did see patterns in both x and y, all right? So how do we see those patterns? We looked at a table. We had very simple integer numbers, and we basically counted. We said, what's the count in the x? What's the count in y? If you remember, we talked about delta x's and delta y's, right? What do? We put a table down, and we talk about a delta y and a delta x. What's delta y? It's the change in y's. What's a delta x? It's the change in x. All right. The ratio delta y over delta x is going to be defined to be slope. And that slope number has an abbreviation m. The computation for that, given points, is this computation over here. Most students prefer to do this, a formula, than they prefer to do something else, which I'm going to write down now. You may also want to think about this as being a rise over a run. I'm going to draw a little picture. I'm going to put points in the picture. I'm going to call this P1. I'm going to call this P2. This is X1, comma Y1. This is X2, comma Y2. And what I want to do is I'm going to just talk about a run and a rise. And I'll emphasize what we mean by this. This here will be the run. This here will be the rise. And I'll put this down for you. This distance here is called the rise. And this distance here is called the run. We need to know those distances, by the way. Rise is also called delta y, and run is also called delta x. All right, slope is defined as being the rise over the run, or the delta y over the delta x, or the change in y. Now, someone says, what works? Whatever works for you. Like if you think rise over run works for you, that's good. If delta y over delta x works for you, that's good. If change in y over change in x, whoops, this is in. If that works for you, fine. Let's talk about the formula. I do want to claim the formula. I want to put this point over here. And this point's not on the line, by the way, is going to be what? X2, comma, Y1. Well, if I were looking at the change of this gravity, I want to point what change means. There's a change in the Y values. The Y's are what's going up and down here, not the X's. The X's are always going to be X2 here. So what's change going to be? Upper minus lower. So Y2 Write this down for you. Minus y1. Okay, let's talk about the change in x now. If I look at this over here, this is the change in x. It's called a run. If you notice over here, the y's are not changing. Always going to be y1. What's changing? Just the x when we left, right? Upper minus lower, x2 minus x1. All right, there's a visual picture of that. All right, most students go for the formula. Most students go for the formula. Let's go back over the notes and let's talk about it. All right, and let's take a really simple example here. And I'm going to look at this example over here. I'm going to push this to the side. And I got a line over here. I'll write this down for you. And the line is 3x plus 5y equals minus 1. Well, we've been doing this for some time now, and I'm going to write this down. I'm going to write down, points that look easy for me to deal with. And again, when I'm saying they're easy, I'm not going to say for everyone they're easy, but I'm going to say, I don't know, minus 2 for x and 1 for y. Now, why is that? Because 3 times minus 2 is minus 6, and 5 times 1 is 5, and minus 6 plus 5 is minus 1. That worked out beautifully. And again, I know it's a struggle. We don't want you to struggle too much, but we do want you to try. There's no doubt about it. We want you to try. Let me try another one. And another one, what would you do there? Let's take a look. And I guess, let's see. That's a tough one, isn't it? So I'm going to think about that. And we want you to think too. Let's take a look. I don't think I want to choose 0, right? Because, 3 times 0 is 0, and then get 5, y equals minus 1. If I try 2, 3 times 2 would be 6. I take it from both sides, that'd be minus 7. That doesn't look good, neither does it. Let's try 2. I just said 2, right? Let's try 3, that's 9. I think 3 is going to work. Put this over here. Don't be discouraged if it doesn't work. Let's put this down. 9 plus 5y is equal to minus 1. 5y is equal to minus 10. Well, y would be minus 2. All right, now we can play this game all day long if you want, but I think you probably know what I'm going to do, what I did in the past. Let me erase this business over here. I want to see if I get a pattern to this problem. Let's talk about this. And you know me, I always like to go in the same direction. What's a delta y? Well, if you're at 1 and you get to minus 2, I hope you realize at least you went down. How much? 3. Again, we know this is a struggle. We want you to try. We really do. What's delta x? If you're at minus 2 and you got to 3, I hope you can agree you went up in value. So it's positive. So I'm going to say it went up by 5. All right. Now someone says, could you keep counting? I could. What's the next value going to be? Well, on the x's, I go up by 5. This would be 8. On the y's, I go down by 3. So this would be minus 5. Now, not that I want to do it, but I'm going to check this. It should be 24 minus 25 equals minus 1. That checks out beautifully, but that's not my intent. My intent is to write the slope down. And what's a slope? Well, I hope I can remember this. Slope, and we're not saying you're going to do it this way, is equal to delta y over delta x, or the rise over the run. These are conceptual. What's the rise? Minus 3. What's the run? 5. And that's fine. If you did slope that way, it's fine. I'm going to use formula. When I write the formula down, I write down P1. That's minus 2, comma 1. That's the first point we got, remember? And P2 is the point 3 minus 2. This is x1. This is y1. This is x2. This is y2. What's m? I'll write the formula down for you. It's y2 minus y1 over x2 minus x1. What do you get over here? What's y2? Minus 2 minus 1. That's y1, right? 3 minus a minus 2 is plus 2. What do you get there? Minus 3 fifths. Okay, let's go through this again. Conceptual formula. Do we get the same answer? Of course we do. That's the slope of the line. There's another way of getting it. And it's kind of like my favorite way. I'm going to talk about my favorite way of getting it. So if I see the equation 3x plus 5y is equal to minus 1, I'm going to try to solve for y. And watch what happens. 5y equals minus 3x. I took 3x from both sides, minus 1. Divide both sides by 5. You get y equals minus 3/5 x minus 1/5. All right, I want to point out this is probably the most famous form of the equation of a line. And what's the form going to be? Y equals mx plus b. Let's talk about it in stages. What's the m? This is the m. What's the m? The m, as we know, is minus 3/5. Then this is, what's this thing over here? This is the b. What's the b? Well, let's write this down. The b has something to do with the y-intercept. If x is 0, I get minus 1/5. So it's the y-coordinate of the y-intercept. All right, that's a lot to handle at this point over here. But we'll go through examples. As we go through examples, maybe we'll do it by points sometimes. Maybe we'll do it by a visual sometimes. Maybe we'll do it by solving the equation for y. We need to go through examples though. And certainly we'll do that. Thank you.